Hello, this is John Weng. Auto programming for general purposes. This is a series paper. Outline, I talk about why APFGP, that stands for auto programming for general purposes. Agent FA, attentive agent FA, GeneSema tooling machines, that is optimal. Auto programming, motivation, church Turing thesis, extended and its proof, experiments, and discussion. AI is in a crisis. AI is hard, mainly by media hype. AI is in the wrong track, mainly because of post-selection. AI lacks brain understanding. In the sense, there's no APFGP. Since 2015, all 15 AI papers in Nature are flawed in experimental protocols. The detail is available on this link. Multiple billion-dollar question, the frame problem, cursor dimensionality problem, internal representation problem, nonlinear control problem, local minima problem, and computer hardware problem. The work addressed the green issues that are largely solved, but probably not directly computer hardware problem. Hugh Dreyfus has a book titled What Computers Still Can Do. In his book, he mentioned non-formal intelligence, human APFGP, children build a toy house, adults also do auto-programming for general purposes, and why robot needs to do APFGP. We generalize our questions. We build not just a house or car, but anything, minimum set of mechanism. Here we approach holistic solution to the multiple billion-dollar problems we talked about earlier. Probably not quite computer hardware problem, which demands technology advance in real-time chips like FPGA and ASIC chips. Key in this AI revolution is that robots learn on their own. For example, robots initiate, design, and make any new things themselves. The book I published categorized tasks into 3 categories: clean tasks, muddy tasks, third, very muddy tasks. They include learning new muddy subjects and creating new knowledge of high value. So this is related to what Dreyfus was talking about. Agent FA, traditional FA, use state to denote context or input string. The output is to indicate whether accept or not yet. An agent FA, by our definition, output state. So the state is output to the word, not just accept or not yet. Attentive agent FA, the input at any time t has multiple objects or symbols. For example, in the street, you can have multiple cars, multiple traffic signs, and multiple pedestrians. Theory 1 said the control of a Turing machine is not only an agent FA, but also attentive agent FA, because the FA will attend one of the object or multiple of objects at any time. GeneSema is the acronym for 8 properties: G for grounded, E for emergent, natural, incremental, scout closed, attentive, motivated, abstract. Turing machine is simple but very powerful. It has a tape, a read-write head, and a state transition table. When symbols are not grounded, you have Turing machines. You're given a known task, a programmer construct a Turing machine to carry out that task. The controller is a 5-tuple, 1, 2, 3, 4, 5, previous state, input symbol, next state, tape symbol that writes to the tape, and the motion of the head. When symbols are falsely grounded. We use sensors to sense the real world, but it's not correctly grounded because symbols in the transition table are handcrafted. ImageNet is like that. When neural networks are not grounded, we may have a network input lines are symbolic, and each line corresponding a meaning, and on means the meaning is present and off means not. When neural networks are falsely grounded, so neural net may use sensors, but they have a problem in protocol called PSUTS, post-selection using test sets. You can use human to do PSUTS or machine to do PSUTS. Perception by me and my co-workers and EM didn't do PSUTS. The control of a Turing machine is FA. You expand the state from the original state to tape output and head motion. And you can prove that you have a transition table just like FA. And let's look at the difference between the symbolic machine and the emergent vectors. This is the transition of a finite automata. State queue and input symbol go to next queue. Then you look at next symbol. And emergent transition, you convert those symbols into vectors. Those vectors are directly from sensors and muscles of the motor. Then you add hidden area Y. Then you unfold time 0, 1, 2, and 3 continue on. 0 means inception time for the life. And this T runs very, very long across life. Then the mapping becomes very clear is Y take input from XYZ, Z take input from YZ. Developmental network addresses mapping from left column to right column. The model brain is highly recurrent because you can see that it's a highly recurrent, it's going go up and down many times across time. Unified XYZ as a context, transition of the context to the next context. And the network, you have a hidden area, you have a multiple object in X, you have multiple area in Z, and the transition through time over here is collapse the time, then you have a 6 field for each neuron. And we need to talk about each neuron does feature detection, and we call local component analysis, LCA. Each neuron has excitatory connections and inhibitor connections. Each neuron detects an area in the input space. In our case, X could be sensory input and vector input from Y or Z. Then each neuron corresponding cluster I called a principal component region, and each region represented by each neuron called R. Because different normalization, you can end up with each neuron detect different kinds of lobe components. The top K computation is essential, where each neuron X bottom-up input match the bottom-up weights, top-down weights, bottom-up weights, input from context Z, input from sensory input. Then the inner product becomes the pre-action for potential. Then you compute among the Y neurons, IJ, and the winner will fire and update. Maximum likelihood optimality of emerging Turing machines, the theorem said that by learning from any teacher Turing machine, regular or universal, through patterns with top 1 filing in Y, the DN control enables a learner synergema Turing machine to emerge inside it with the following properties. When you have sufficient neurons and it's error-free, because that's optimal in terms of the maximum likelihood. If you don't have insufficient neurons, because all the neurons have activated through incremental learning, then all the neurons that updated are optimal through time, but not error-free anymore. In other words, this theory already addressed the local minima problem and curse dimensionality problem. If you have regular Turing machine and it's a special purpose, you're given a known task. Human design a specific machine to address the problem. And universal Turing machine is general purpose because the external world has program and the data. Then the DN realized universal Turing machines. Attentive versus Genesema Turing machine, suppose you have attentive AFA, you have symbol, state symbol, then you go to time t, move along. Then the Genesema Turing machine has a vector to represent Q, X represent sigma, that's vectors. Then Y representation will generate internal feature, and internal feature will move to the next Z. If you have a supervision, then Z is supervised by bar. Originally, you don't have supervision. This 0 means could be innate, could be overridden by external Z. Sensory input, it could be predicted from innate behavior or overridden by external word. And because each area X, Y, Z computing parallel, you have two parallel passes. Here X, Y, Z, and Y go to XZ, and XZ go to Y, and this is the same time, and go on like that. Theorem said auto-programming. A Genesema Turing machine inside DN automatically programmed for general purposes after it has learned universal Turing machine TU and the related purposes. However, the DN algorithm itself is task independent and language independent. For example, English, Chinese, those are natural language, or computer language, could be like C language. Compare among machines, there are Turing machines, universal Turing machine robots that are grounded, prior neural networks, and the new Genesema Turing machines, the only machines that can do auto-program for general purposes. And the prior neural network cannot do it, and the some of neural network are partially emergent. Motivation, so far we talked about two kinds of neurotransmitters, excitatory and inhibitory. There are 4 types of neuromodulators called serotonin, dopamine, acetylcholine, and norepinephrine. Serotonin is for something like pain and stress. Dopamine is something for pleasure and wanting. Acetylcholine for expected uncertainty. Norepinephrine for novelty or unexpected uncertainty. For detail, you probably should read the book by myself. Grounded universal Turing machine will include multiple Turing machines and one or multiple universal Turing machines. And this is the example where you have 2 tasks, 1 and 3 in the paper, but don't worry which tasks. These tasks are relatively simple, so they can construct a transition table. Instead of symbol, we have vectors, binary in this case. And instead of input symbols on the tape, we have vectors. And there are 2 tasks learned. And if we drop symbols, it becomes binary. And you probably will not be able to understand the firing for a spiking neuron in the brain. But if we have original meaning of symbols, then these binary patterns are beautifully clear. Churchy-Turing thesis says a function on natural numbers can be calculated by a paper and pencil method if and only if it is computable by a Turing machine. According to Wikipedia, this thesis cannot be formally proven. But I extended Churchy-Turing thesis and also proved it. Theorem 4 said that for any machine, natural, artificial, the following A, B, C, D are equivalent in terms of computing engines. A, B, C, D is explained here. A means a grounded universal Turing machine. B, any paper and a pencil method. C is a Turing machine computable. And the proof start from A to B to C back to A. And A is the most powerful, B is intermediate, C is the most basic. For experiment, we have a vision that has a stereo camera and a GPS camera perception for the local environment and automatic integration learning on the fly, incremental, and learning skills from experience. We also have audition for any sound, not just phonemes, experiment with the language acquisition for a bilingual environment of French and English. AI ML context discussion. For simplicity, wide-to-wide connections are not discussed here. Meanings emerge as actions through APFGP. Although computation is numeric, but the meaning emerge through the patterns. The patterns, internal and external, are from real world, has its own intrinsic meanings. A wide acceptance of APFGP for artificial intelligence may take many years, but this will lead to an AI revolution. The greatest enemy to this revolution is our own washed brain. For example, not interested in detail of fundamental problems in AI. And currently there is also lack of education in AI necessary subjects. Thank you.